Hey guys, Smart for You is here, and I'm back with another video. Sorry, long time no uploading because busy with school and all that life, of course. But let's just start from now. I'm gonna do a mix and match of certain subjects and certain grades. Like for example, today I'm starting grade 10. Tomorrow, whenever I might start grade 11 or 9, wherever I think of it. So, today we're going to start with this topic. Primary trigonometric ratios. I already drew my triangle and everything right here. You can see it. Okay. So, each of these side lengths has a name. These are the three names. Opposite, adjacent, hypotenuse. Of course, I named them with the first letter they started with. Opposite, adjacent, hypotenuse. So, since we know now what are the names of the side of the triangle, but listen, these will never always stay like this. Not always. If the angle is right here, these two switch. This becomes opposite. This becomes adjacent. But since we're talking about the angle as it being here, and of course it's called theta, then it's like this. Adjacent of that angle is here, opposite of that angle, and the hypotenuse is always here. So now let's actually solve for a triangle. So let's say we have this triangle over here, and let's call it triangle JKL. JKL. The J is so weird. JKL. Oh, oops. Okay, JKL. And let's make up the side length numbers. So let's say this is 19.5. Just getting this random. Let's do, because it's opposite, the reference angle is here. Because it's opposite, so it's the smallest, so let's just say 7.5. And here, adjacent, let's just say, no decimals, 18. Let's just say that's 18. So, now, the question is, I want to ask you this question. Tell me the sine of this. Now, if you don't know what sine is, let me give you in another way. Using a small marker. So sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent equals opposite over adjacent. Oh. Opposite over adjacent. Now, I want you to tell me, what is the relationship between sine? What is the relationship of sine? So first you want to see what is sine made out of. opposite over hypotenuse. So now let's look at this. Our opposite is 7.5. Our hypotenuse is 19.5. You actually divide it. So I'm going to use my calculator here. 7.5 divided by 19.5. You should get 0.3846. No rounding. Since we got that, we are done. Now we know the relationship of sine. What is sine of this triangle? Opposite of hypotenuse. Opposite 7.5 over hypotenuse 19.5 equals this. Now, most people get mixed up with opposite and hypotenuse. Why? Let's say it's here. How do you know which is the longest side, which is adjacent? I mean, opposite, not here. Most people, for example, let's say I wanted you to find cosine. They're going to see 18 here, 19.5 in the reference angle right here. Most of them would think this is the hypotenuse, this is the opposite. That's wrong. Hypotenuse is the biggest side. If you do not have a numerical value, that is if you find the numerical value of the largest side, that's the hypotenuse, pretty much. The opposite is always the second largest, the adjacent is always the second largest, and opposite is the smallest. Now, how would you know if you do not have a numerical value? That's when you actually have to find out. So if you have this number and this number, and no number here, let's say this is covered. Using Pythagorean theorem, 7.5 squared plus 18.5 squared equals c squared. Doing the calculations, you should actually get 19.5. And if you get a high number, that means that's the longest side. You can find that out by that. So that's the easiest way of finding these two. So now let's say you have this triangle. More of a turned triangle from the other one. And let's make up dimensions. Let's just say this is 11.4 and this is 8.7, and our reference angle is here. Now, I can think of any numerical value right now, but I want to calculate and know what value we need. So let me show you an example. You want to find here. So what do? Pythagorean theorem. This is the longest side, so this becomes C. This is A or B. This is B. Let's just say this is A, this is B. It's a C. And Pythagorean theorem is a squared plus b squared equals c squared, right? Let's write it here. A squared plus b squared equals c squared. Since we don't have, let's say, b, we're going to have 8.7 squared equals plus b squared equals 11.4 squared. Now, there's ways of doing this calculation. So, you want to solve for b squared, so it will move 8.7 squared there. So it becomes b squared equals, let's just do b equals 11.4 squared plus 8.7, no, minus, sorry, it's always the opposite, minus 8.7 squared, and we square root all of that. This should give us, using a calculator, so I'm going to use my calculator, 11.4, no, let's just do it all together. So the square root 11.4 minus 11.4 squared minus 8.7 squared and then we square root it, which should give us 7.36. Round it all off, should give us 7.4, 7.4. Now we know all sides. Now, let's say I want to know the cosine of this triangle. So the relationship, looking at here, it's adjacent over hypotenuse, right? Adjacent is 8.7, hypotenuse is 11.4. So I'm going to do adjacent, 8.7, over hypotenuse, which is 11.4, equals, should give us, rounded it all off, 0.7632. Now we know the relationship of cosine in this triangle using adjacent and hypotenuse. Now most of you guys will ask, what if you want to use sine or tangent? Anything will come up with this answer. No matter what relationship you give, has to follow sine, cosine, tangent, it will always give you this. Let's do sine. Sine is the opposite over hypotenuse. 7.4 over 11.4. Let's go on the calculator. Let's do here 7.4 divided by 11.4, 0.7. Yep, same thing. 0.7632. If you round off that number that we got, same number, same thing. It always occurs that way. Now, we probably right now memorized everything in here. I hope you memorized the sine, cosine law, sine, cosine, and tangent, what does their relationship are. Sine is always opposite of our hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So, let's draw this triangle. Okay, let's see the reference angles here. And we have 480. I got this off this paper. 480, 480, and 680. 680 millimeter, millimeter, millimeter. Now, I want you to solve using the relationship of tangent. So tangent is always opposite over adjacent, like what I said. So opposite 480 over adjacent, which is 481. Easily. That's how you find out. So now you should be familiar with this primary trigonometric ratios. We are not done yet. There's still more content to this. So now let's say we're going to use scientific calculator. Got my phone, scientific calculator. And let's just say, let's start, let me just say we're gonna have a angle or a degree, a certain degree. So, how do you solve for it? What do we do? Let's say, using my notes right here, seeing it here. Let's use this example. Sine of 25 degrees. Now, going to our scientific calculator, we're going to do 25 of sine. We should give us 0.4226. 0.4226. Another way of saying this, we can use opposite of our hypotenuse will give us the same thing. But because we don't have a triangle, but we only have a degree, we have to use the degree. If I had a triangle, they give us a triangle. Using the opposite of our hypotenuse, we could have got the same answer. Had to be always, always, and always. If the angle is 25 degrees. So let me make up this one. Cos of 57. Nah, let's just use 56. Cos of 56. Now we're gonna do 56 cos. We should give us 0.5592. 0.5592. Let's go for tan. I'm gonna choose tangent tan of 78. My favorite number. So then we're gonna go here, 78. Tangent should give us 4.705. Oh wait, that's not 4-digit. Oh no, that's not 4-digit. 4.070. Wait, 4.07046. Sorry about that. I'm gonna stop with the calculation. It's supposed to be 4-digit. Always, when doing this using the degree, it's 4 digits, 4 decimal places. I want to give one more example. Let's do... sine of 15. Sine of 15. So this will equal, so we're going to do 15 sine, you should get the hang of it right now, 0.2588. Pretty easy stuff. Not hard. Just need to learn. how to actually do it. You know what? Let's do one more. I'm feeling it. Let's do tangent of 2. Tangent of 2 should equal, so 2 tangent of 2 is 0.034. 34, and what is the next digit? 9. 0.0349. We should already now get it. It's pretty easy. It's mostly calculator work. Nothing to be really needing of knowledge, but only to know how to use a calculator. Now, let's see. Let's do this. Next example. So, let's say we have sine of theta equals 3/4. So now, because we have sine of theta, that means we have to do inverse of sine to find a degree. So how do we do this? So now we're gonna do second function. Always in your calculator, there's a second function. Second function sine. Second function 3 divided by 4 sine. Wait. Second function of sine 3 divided by 4. Oh wait, made a mistake. 3 divided by 4. Oh wait, 3 divided by 4. Let's see this. Let me fix this right now. Let's ignore the phone right now. I brought my actual calculator with me right here. So now let's test it. So we got sine of theta equals 3/4, right? We're going to do inverse of sine. Inverse of sine 3 divided by 4 should give us 48.59, which in total should give us A, or let's just say theta equals 49 degrees. And let's say another example. Tangent. Let's do this. Tangent of theta equals 1.5012. 1.5012. Let me make this a meter. 5012. Same thing. Theta equals, and do inverse of tangent. 1.5012 gives us 56.33, or another way of saying that is 56 degrees. Done. Let's use another example. Got one. Tangent theta equals 5/7, and then theta equals, I'm going to go to inverse of tangent. 5 divided by 7 equals 35.5, or another way of saying 36 degrees. Now, after this, I want to just bracket this for a little bit. Look at here. This is what we got. Now, I want to go back to what I said in the beginning, if I did say it. So, about that in grade 11 there is 6 trigonometric ratios, while in grade 10 there's only 3. So let's talk about them right now. We know, sine, cosine, and tangent. These are the regular ones. The other 3 are secant, cosecant, and cotangent. So what these are just the opposite of each other. So sine is opposite over hypotenuse, right? Secant, which is the opposite of sine, is just hypotenuse over opposite. Cosine, which is adjacent over hypotenuse. I almost forgot what that is. Cosecant is hypotenuse over adjacent. Tangent, which is opposite over adjacent, and cotangent is adjacent over hypotenuse. Opposite. So, why did I tell you this? It's a simple thing. They're pretty simple. Just if it tells you, for example, for this one, 3 over 4 gives you 49 degrees. What is the opposite of it? 4 over 3. Going back, 4 over 3, so opposite of sine, 4 divided by 3, gives you your domain error. Not good. But, what is 3 over 4? What does 3 over 4 mean? 0.75. What is the opposite of that? 4 over 3, 4 divided by 3, 1.3. So, that doesn't matter. So, if any question, let's say you're in grade 11 and you're taking functions university, and it gave you secant 4 over 3, that means it's the opposite of sine, not like a different it's not like a new type of trigonometric ratio. It's just the opposite of this trigonometric ratio, which is sine, which is cosine, tangent. That's the opposite. So, guys, I will end the video here. It's been already 28 minutes of recording. Sorry for the long video, because a long time I haven't made this video yet. So, going back to what I said, I'm going to start uploading more videos. Hope you guys like this. From tomorrow, or maybe today, I'll make another video. I don't know, but you might see daily uploads from now on. But I will not upload on Sunday and Saturday. Maybe Saturday, but never Sunday. These days, I'll take my time off, but the regular days, Monday, Tuesday, Wednesday, Thursday, Friday, I'll be sure to upload every single day on that time, and maybe Saturday. So, thanks for watching. Please like, subscribe, and share, and comment if you want a shorter video or a longer video. But tomorrow we're going to continue it. Tomorrow we're going to learn about solving right triangles. Or maybe we're going to go to grade 9 stuff. But I think we're going to do tomorrow, keep doing grade 10. This unit right now, for me, I'm looking at 6.0. That's my own unit. 6.4 tomorrow. 6.5, which is which is going to be Thursday, which is solving right triangle problems. So, thanks for watching. See you later. Peace.